These are the lesson 2.1 notes on multiplying fractions and mixed numbers. We have been working with a rectangular model and using that to show a picture of what it looks like to multiply fractions and mixed numbers. But sometimes that gets difficult when the numbers get big, so it's nice to be able to move toward a rule. So the rule that we use for multiplying fractions is that you multiply the numerators and then you multiply the denominators. So multiplying is much easier than adding because you do not have to find a common denominator. So an example there is that 3/7 times 1/2, you can multiply 3 times 1 and get 3, and 7 times 2 to get 14. 3/7 times 1/2 is 3/14. And then practicing looking at that algebraically, A over B times C over D equals A times C over B times D. And we're not allowed to have B or D be 0 because you can't divide something by 0 and get an answer, right? It's what we call undefined. It's just something you're not allowed to do. Right? So for example 1, if we want to multiply 1/5 times 1/3, we can multiply the numerators and denominators. 1 times 1 is 1, and 5 times 3 is 15. And then you always have to check to see if that can be simplified, but of course this one can't because the numerator is 1. Okay, you have 2 you tries. In example 2, this is a great trick which some people know how to do and some people don't. We are going to look at fractions that have common factors. Okay? So when we look at, and we're going to cross cancel them. Cross cancel. Right? So 8/9 times 3/4. All right. I'm looking at 8 and I see that I can rewrite 8 as 4 times 2. And then I have a 4 in the numerator and I also have a 4 in the denominator. So I can cancel out those 4s. And I can rewrite 9 as 3 times 3. And then I have a 3 in this numerator. Kind of change that into a 1. And a 3 in this denominator. And those can cancel out. Think about what that means. If you have 3 in a numerator and 3 in the denominator, that's the same as having 3 over 3, which is the same as 1. So they will cancel out. Same with the 4s. 4 over 4 is the same as 1. So you can cancel those out because when you know that when you multiply by 1, it doesn't change the number. And then all that's left is 2 here and 3 here, and everything else is gone. So my answer is 2/3. If you didn't do the cross canceling, what happens is that you have big numbers. 8 times 3 is 24, and 9 times 4 is 36. Not huge numbers, but certainly bigger than 2/3. And then you have to remember to simplify at the end. 24 divided by 12 is 2. 36 divided by 12 is 3. So you get the same answer. But I like very much to cross cancel because it gives me smaller numbers to work with, so I'm less likely to make mistakes. And it also means that I will have less simplifying to do at the end. Sometimes you do still have to simplify, but it won't be as much. I'm going to do another example because I know that's new, and we will probably need to do some examples of that in class too. Let's do about 7/12 times, 14 over 35. All right. So those are some pretty big numbers. Now, if I was multiplying 7 times 14, ooh, that's big. So is that 89, yeah, 98. And 12 times 35, I can't even do that. I would have to write it down or get a calculator. The number would be so big. But if I cross cancel, I've got 35 is 5 times 7. And I can rewrite 12 as 2. Did I want to do it? Yeah, 2 times 6. And 14 as 2 times 7. Oh, this is going to be fun. All right, so now I've got a 7 here. And I've got a 7 here, and I also have a 7 here. You can cancel out either one, but you can't cancel out both. All right, any numerator with any denominator. So there's a 7, and here's a 7. I'll do that one. And let's see, here's a 2, and here's a 2. Are there any more common factors? I don't think so. 7's a prime number, so I can't break it down anymore. 5 is prime, and 6 is 2 times 3, but that won't go into 7, so I think I'm done. All right, so that's all gone except for the 7. And 6 times 5 is 30. Okay, so much easier multiplication than if I had those really big numbers and then I was trying to find a common factor. All right, what else did I want you to see there? Oh, here I could have multiplied, like I could have made 12, could have been 4 times 3, but then it wouldn't have had a common factor with 14. So you kind of have to feel around a little bit to see how to break these down so that you have a common factor. But you know you have a 2 in them because they both are even, right? Practice this because that's a really powerful skill. All right. Example 3. Let me make that a little bit bigger. Okay. Is the real life example. You have 2/3 of a bag of flour. You use 3/4 of the flour to make an empanada dough. How much of the entire bag do you use to make the dough? All right, so we go back to that part of a part idea. Let's see, you have 2/3. And you're going to use 3/4 of it. So you're going to use 3/4 of the 2/3 that you have. Is that better? Okay. We're going to do it both ways. We're going to do it with a picture, and we know that of means to multiply. I think that's especially powerful with fractions and also with percents or decimals. That's a really useful thing. Okay, so 3/4 of 2/3 is 3/4 times 2/3. And you know from the rule that you can do 3 times 2 is 6, and 4 times 3 is 12. And then you can simplify that down to 1/2. Or you could have cross-canceled. The 3's would cancel out, and you would be left with 2/4 was 1/2. Or you could even cross-cancel and make that a 1 and that a 2, and it would simplify down to 1/2. Okay, let's look at that as a rectangular model because we've been doing that in class. Let's do a rectangle. So this rectangle is one whole bag of flour. All right. And then let's divide it. We're going to divide it into 3/4. So let's do 4ths this way. I'm going to shade 3/4. I should have done it the other way first. It would have fit our story better. Okay, and then the other direction is 2/3. I'm going to divide it into thirds. Okay. Now we'll put the words with it so it fits our story better. So we have 2/3 of a bag of flour is this green amount. So there's a whole bag, 2/3 of it is green. That's how much is left in there. And then we're going to use 3/4 of that 2/3. So you can see here's 1/4, 2/4, 3/4 of the 2/3. So this part that is double shaded is your answer. And how many parts do we have? 1, 2, 3, 4, 5, 6. Out of 4 times 3 is 12. And you can see that if you multiply the two denominators together, they give you the total number of pieces in here. And then if you multiply the numerators together, it gives you the part of a part. Okay? You have a you try. Multiplying fractions and mixed numbers, right? This is the new material. For these purposes, when you are multiplying a fraction and a mixed number, you need to make it into an improper fraction before you can start multiplying. Now, I will kind of interject that we did some break apart in class where we looked at 2 and 3/4 as being like 2 plus 3/4. So if you have numbers that work nicely, it's okay to say half plus 2 or half of 2 and then half of 3/4 and add those together. That works just fine, especially if the numbers are easy to work with. But if the numbers start to get tricky, it's nice to write them down. Right, so we've got 1/2. We have to change that 2 and 3/4 into an improper fraction by saying 4 times 2 is 8, and 8 plus 3 is 11. It is not plus, it is times. All right, so we've got 1/2 times 11/4. Let's see, 2 times 4 is 8, 9, 10, 11. Yep. And then I always like to check and see if I can cross cancel, but 2 does not go into 11. No, I just have to do the multiplication. 1 times 11 is 11. 2 times 4 is 8. You may leave it like this, or you may change it into 1 as the 8, 9, 10, 11. 1 and 3/8. I feel like we should do another one of those. Yeah, let's do another one. Those are pretty tricky. Let's do 5/6 times 4 1/2. Okay, so here's one that's a little bit harder to think about. It's not easy to say 5/6 of 4 plus 5/6 of 1/2, right? That's harder to do in my head. So I'm going to write 5/6 times 2 times 4 is 8. So that's 8 halves plus 1 more half is 9 halves. Okay, and then check and see if you can cross cancel. 2 and 5 don't have any common factors, but I can rewrite 6 as 3 times 2, and I can rewrite 9 as 3 times 3, and then I see that I have a 3 in both of those. Right? And then I've got 5 times 3 is 15, and 2 times 2 is 4. And again, if these don't have any factors, it's okay with me if you leave them as an improper fraction, unless the problem tells you to make it a mixed number. But But we can make this into a mixed number. Let's see. 4 will go into 15 3 times. 3 times 4 is 12, 13, 14, 15. 3 and 3/4. Okay. If we were in class, I'd say, any questions? Okay, so you have 2 U tries. Okay, and then the last hardest ones, I think that these are the trickiest ones, except for, so I still think that subtracting fractions is the hardest thing. But these are a little tricky because you have to change both things into improper fractions, right? So start, do you want to show? By the time you are looking at these notes, we will have done a rectangular model. I wonder if I want to do that. Where you will, I'm going to do a rectangle over here. Okay, let's first do it just with the numbers, and then we'll compare it with the rectangle. So we've got 5 times 1 is 5, and plus 4 is 9/5. So 1 and 4/5 is 9/5. And 3 times 3 is 9, plus 2 more is 11/3. Check to see if you can cross cancel. Yes, we can. 9 is 3 times 3. So I can cross out a 3 there and there. And then 3 times 11 is 33. And 5 times 1 is 5, which is 6 and 3/5. All right, so let's do this picture. It might be a little awkward because fifths are kind of hard to draw, but I bet we can do it. All right, so I need a rectangle. I'm going to round this up to 2, and I'm going to round this up to 4. So let's do a 2 by 4 rectangle. I'll kind of make it as big as I can to fit in there. Okay, let's go ahead and divide it into 2 this way, and into 4 this way. Okay, but it's not 2, it's 1 and 4/5. So here's 1, and then this little space I need to divide into fifths. So I'm going to draw 4 lines. 1, 2, 3, 4. So now I've got 1 and 1, 2, 3, 4, 5/5. So I'm going to kind of shade in one of those fifths to show that it is going away. So now what I have left is 1 and 4/5 this way. And then this way is 3 and 2/3. So I've got 1, 2, 3, or actually I should say 1, 2, 3. And then this space is going to be divided into thirds. And I'm going to keep, notice I had to draw the whole line, okay? You're not just dividing this one, you're dividing the whole space. I'm going to keep 2 of those, and I'm going to shade in the last third to show that it's going away. Okay, and so this is 3 and 2/3. 1, 2, 3 holes and 2/3. Okay, so hopefully what we see are 4 different sized spaces. You see a space here that is whole numbers. It is a 1 by 3 space, 1 by 3. Let's see, so we're going to do, I don't want to do that. Just right. Okay, 3 holes. Color them blue. And then you have some pieces here. These are fifths, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fifths. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fifths. Okay. I hope this works out. I didn't practice this part ahead of time. Okay, and then over on this side, these pieces are thirds, right? This whole is divided up into thirds. And I have 1, 2 thirds. Okay. And then how about yellow for that last part. And then these little guys are 1, 2, 3 times 1, 2, 3, 4, 5. These are 15ths over here. This whole is divided up into 15 pieces. So I have 2, 4, 6, 8 15ths. Okay, so when I divide it up into a rectangle, I have 4 different sized pieces that are generated by multiplying. If I have 1 plus 4 fifths times 3 plus, whoops, you can't see that, 3 plus 2 thirds, I do 1 times 3. That was the blue part, right? That was the whole numbers. I don't want to color the number. I'll make the arch that color, all right? And then I've got 4 fifths times 3. Well, if I do 3 times 4 fifths, that's 12 fifths. So that's this part. And then if I do the, let's see, I've got 1 times that. Let's do it the other way. Let's go the 2 thirds times 4 fifths. Let's see, 2 times 4 is 8 15ths. Yep, there's 8 15ths. And then the last part is from here. Maybe I'll go this way. From here to here. 1 times 2 thirds is 2 thirds. Okay? So when you get into algebra in 2 years, you'll be doing this. You'll be multiplying 2 numbers by 2 numbers. And this is a great model. We call that multiplying binomials. This is a great model for that as well. And then if we took all of our parts, should we do that? I bet we can, because I can use a denominator of 15. So let's do, let's see, 12 15ths plus, sorry, that was 12 fifths. Okay, 12 fifths plus 8 15ths plus 2 thirds plus the 3 wholes. Let's change these all into 15ths. We've got 3 plus 5 goes into 15 3 times. 3 times 12 is 36. Yep. Okay, 8 15ths. 3 goes into 15. 5 times 2 is 10. I wish I had told you back before you started. You're probably scrambling trying to do this, aren't you? This part's okay, all right? I wanted you to see it. I didn't mean for you to have to draw all that. I'm sorry. Make sure that you have this part, okay? And you can stop trying to draw that picture. All right, let's add up. 36, 46, 54. Is that right? 36, 46, 54 fifteenths. So we've got 3 and 54 fifteenths. How many times does 15 go into 54? I guess it's going to go 3 times. So I'll add on here. It'll be 6. And how many more will be left? That's 45 and 9 fifteenths. Oh, it's going to work out. It's really hard when you do a really long problem and then you get all the way to the end and it doesn't work. It makes me very sad. But this time, my math was right all the way through. Okay. Ta-da! Okay, so now you have 2 to do. You do not have to do the picture, okay? You do need to change it into an improper fraction times an improper fraction. Check to see if you can cross cancel, and then check again at the end to see if it needs to be simplified. Whew. Okay, one more problem. This one's not too bad. This is the real life example. Right? A city is resurfacing a basketball court. Find the area of the court. So to find the area, you know that area is equal to length times width. And that's exactly what we've been doing. We've been using a rectangular model for area. So we're going to do length. I always think that's the long side. 21 and 1/3 times 13 and a half. Okay, 3 times 21 is 63, plus 1 more is 64. And 2 times 13 is 26, and 1 more is 27. Aren't you glad you know how to cross cancel? Because I would not want to do 64 times 27. Oh, it's so much easier to go 32 times 2 and cancel out those 2's. And 27 is 3 times 9. And I can cancel out those 3's. And I still have 32 times 9. I'm going to cheat and use my calculator because it's been a long day. 32 times 9 equals 288. The area is 288 square meters. If I'm finding the inside parts, that would be all divided up into little squares. You could also write that as 288 meters squared. But you can't put the 2 on the 288. It's not the 288 that's being squared. It's the little squares inside. Right? It's like grid paper in there. Okay, those are your very long notes.